Problem 3. In triangle ABC, triangle AEO has an area of 1. So let's first mark that. We know that this has an area of 1. Triangle ABO has an area of 2. Sorry for my writing. I'm using a brand new mouse that I just cut, so I'll go back to the touchpad. So here's 2. And triangle BOD has an area of 3. We're trying to find quadrilateral DCEO. So our first thing that we do is to try to apply the Dovetail Theorem or the butterfly model or both to this problem. After all, it is under that topic. So I'm going to connect O to C. And now we have a Dovetail Theorem, a Dovetail model over here. As you can see, so this from A to C, from D to B to O, that's the dovetail, and it's facing downwards, as you can see. How does a paper airplane? Well, now we can apply the Dovetail Theorem. Out of the values we're given, we can find some ratios between line segments. For example, triangle AOB and triangle AOE both share the height AO, but their bases are different. So that's what makes them different. This is 1, this would be 2, so this is 1 to 2. Here would be 1 to 3. So first, let's call OEC that has an area of x. This has an area of y. And since there are 2 variables, we need 2 equations. So now this is kind of going into a system of equations problem. So first, this is 1, right? So x plus 1, and that compared to y, so this would be x plus 1, and this would be y, so COD and COA is equal to 2 to 3. That's what we have as a ratio here. And as you can see, for the ratios, I am putting them in fraction form, so it's easier to look at and to calculate. And y plus 3 over x, or compared to x, now that's triangle BCO and COE is equal to 2 to 1. So these are the 2 equations, and we're trying to find x and y. So first take a moment to try to solve this on your own, and then we'll get back to the problem. So first we multiply the top equation by y on both sides. So x plus 1 is equal to 2/3 of y. And the second equation is turned into y plus 3 is equal to 2x. So here we can think of y as equal to 2x minus 3. So if we substitute that into the first equation, x plus 1 is equal to 2/3 of 2x plus 3. Well, you keep trying to eliminate the variables and then substitute it back in. And then our final solution should be x is equal to 9 and y is equal to 15. So that is our set of solutions over here, but that's not our final answer because we're trying to find the area of quadrilateral DCEO. So in order to do that, we add 9 and 15, which is 24. So our final answer would be 24.